In this video, we're going to continue using our X factor method. However, in this video, we're going to add that additional step that we skipped in our last video. It's called a regrouping factoring method. We're going to start off with a quadratic that we can use just the basic X factor method for. In that last video, I hinted at the fact that we were skipping some steps when we jumped from our factors that were on the sides of our x's straight into the two binomial expressions. So we're going to start off with a quadratic where a is 1, but I'm going to include those steps that we skipped because we're going to need those steps in the following examples where a is bigger than 1. So let's review the X factor method. We took a times c, so in this case negative 30, we're going to put it up at the top of our x. We're going to take that middle term or b term, which is negative 1 in this example, put it on the bottom, and play a little game where we find factors of the top number that add up to the bottom. Two numbers that multiply to negative 30 that add up to negative 1. That is negative 6 and positive 5. So the most basic X factor method allowed us to jump straight from here down to here into our factored binomial expressions. But I'm going to take you through the two steps that we're actually skipping. So really what we do when we find our factors is that we break up our middle term into those two factors. So negative 1x is now going to be rewritten as negative 6x plus 5x. So I rewrite my first term, x squared. I rewrite my last term, negative 30. That didn't change. I'm going to rewrite negative 1x as the sum of negative 6x plus 5x. So we're just breaking up that middle term. Now what we're allowed to do is group up, this is our regrouping step, the first two terms together and take out the greatest common factor. So the greatest common factor of x squared and negative 6x is just x. So if I divide or factor out x from those two terms, I'm left over with x minus 6. And we can always check by distributing it back in and make sure we get to the step before. Let's group up the last two terms together and take out the greatest common factor of those two. So the greatest common factor of 5x and negative 30 is positive 5. And the leftovers, after we factor or divide that out, x minus 6. If you do that correctly, then these two binomial expressions here should be the exact same. And so if this term has that binomial x minus 6, and this term has that binomial x minus 6, we can actually factor out that entire binomial from those two terms. So if we factor out x minus 6 from both of them, we write x minus 6 at the front, and that left behind an x plus 5. So our leftovers get rewritten last. And if we were to distribute that back in, then we would get back to this step. And if we were to distribute there, we would get back to this step. So you can always check your factoring by backing up a step. So that's really the steps that we skipped in our last video, that regrouping step. It's going to become a lot more important when that a value is bigger than 1. So let's do an example. This time our a value is bigger than 1, and we can't take out a greatest common factor to simplify this quadratic. We're stuck with the way it looks right now, and we got to work with it. If that's the case, we're going to use our X factor method and use that regrouping step to finish off our factoring so we can solve it. All right, so we're going to take our a times c terms, multiply them together. 2 times negative 3 is negative 6. Put it up at the top of your x. Take that b term, in this case positive 1, put it on the bottom, and play the game. Factors of the top that add up to the bottom, or two numbers that multiply to give you negative 6 that add up to 1. That would be positive 3 and negative 2. They combine or add up to positive 1 and multiply to negative 6. So negative 2 and 3 are how we're going to break up that middle term. So we're going to rewrite 2x squared. Now we're going to rewrite our middle term as negative 2x plus 3x, and then rewrite the last term, negative 3. Now we can group up the first two terms. Oh, let me pause for a sec. When you rewrite that middle term using these two numbers, it doesn't matter which order you write them in. I could have wrote 2x squared plus 3x, then minus 2x minus 3. And the following steps would not be the same, but it would work out the end. The final factored form would work out to be the same. So it doesn't matter. It's just a little bit easier if you can recognize which one to put in either spot to make the factoring a little bit more straightforward or easier to recognize. So I put the negative 2x first because I could see that 2 and x would be my greatest common factor. But there's really no other reason that you need to do it. So regrouping the first two terms together, 2x squared and negative 2x, I could take out their greatest common factor, 2x, and that leaves behind x minus 1. Again, distribute to check. 2x times x is 2x squared. 2x times negative 1 is negative 2x. Regroup the last two terms together, and hopefully it's obvious that 3 is their greatest common factor. I could take out a positive 3, and that would leave behind x minus 1. If you ever get these two binomial expressions looking different, either you factored incorrectly at this step, or this quadratic is not factorable, and you got to rely on your quadratic formula to solve. All right, so because we have x minus 1 in both of these terms, let's factor out the x minus 1, and that leaves behind 2x plus 3. So now if we want to solve the quadratic equation, we can start from our factored form here and find the zeros of those factors. So set each of those expressions equal to 0 and use algebra steps to solve. Or you could ask yourself, what makes that expression 0? Well, the opposite of the number involved, a positive 1 would make that 0. I could have got the exact same thing by adding 1 to both sides to solve that equation. Sometimes they're a little bit more complicated, and setting the expression equal to 0 might help you a little bit more just to stay organized. So if I set 2x plus 3 equal to 0, I subtract 3 first, and then divide by 2, and I get my solution negative 3 halves. At some point, you're going to want to be good enough that you could just look at that and think about your algebra steps and jump straight to the solution. So I know I got to subtract 3 and divide by 2, so my solution should be negative 3 halves. So we can use the factors and find zeros of our factors to solve. There's actually a pretty unique fancy shortcut that we can use to solve. So we can ignore our factors here in this form. We can actually just look at our x factors. So those side factors that we came up with in our x technique here can actually give us the solutions. If we just look at the opposite of these factors and divide by our a term, those are our solutions. The opposite of the x factors divided by a are the solutions. So let's see what happens. If I take the opposite of negative 2, that's positive 2. And if I divide that by our a term 2, positive 2 divided by 2 is 1. That's one of our solutions. Let's do it on this factor. The opposite of positive 3 is negative 3 divided by the a term. Negative 3 divided by 2 is our other solution, negative 3 halves. So to factor a quadratic where the a term is bigger than 1, you're going to have to use the x factor and regrouping steps. But to solve it, you got two choices. You can use your factors that you came up with and find zeros, or you can use this little shortcut method and go back to your x and just find the opposite of your factors divided by the a term. However you want to solve. Let's do another example here. This time we're not in standard form first. That's always our first step. Put things into standard form and set your equation equal to 0. So we're going to add 3 to both sides. Now we have 3x squared plus 10x plus 3 equals 0. Let's multiply our a and c terms. So 3 times 3 is 9. Let's write our middle term or b term on the bottom. So we're finding factors of 9 that add up to 10. Sometimes your factors are the most basic factors, the number itself and 1. So 9 times 1 is 9, and 9 plus 1 is 10. So 9 and 1 are our factors. So let's rewrite our original expression by breaking up that middle term into these two terms now. So now we have 3x squared plus 9x plus 1x plus 3. That allows us to group up the first two terms and take out the greatest common factor. So the greatest common factor of 3x squared and 9x is 3x. When I divide those two terms by 3x, I get x plus 3. To take out the greatest common factor of the last two terms is just 1. Sometimes 1 is your greatest common factor. So if you divide out 1, you're left with the same thing. Double check that you have the same binomial expressions here so you can factor that entire thing out. Factor out x plus 3, and that leaves behind 3x plus 1. To solve, you can either set these expressions equal to 0 and solve algebraically, or you can take the opposite of your x factors and divide by a. Either way,